EDX Core Pure, Matrices 1, Introduction and Matrix Multiplication. 1.1 Basic Operations with Matrices. Our definition of a matrix is an array of numbers which represents data or other mathematical information. We define the size of a matrix according to how many rows and columns it has. So the following is a 4 by 5 matrix, and this array of information represents the results of several games of football between 4 different football teams. Here we have 3 matrices. The first 2 matrices, A and B, are square matrices because they both have 2 rows and 2 columns, whereas C is not a square matrix. It has 2 rows and only 1 column. Matrices are often written using capital letters and in bold font when written in textbooks. Adding matrices. Here we have some matrices. In order to be able to add matrices, they must be conformable, i.e. they need to have the same size. So it would be possible to do A plus B. However, if we look at B plus C, these are not conformable. They don't have the same shape, and therefore we are not able to add them together. If we wanted to do A plus B, we would write matrix A, and we would add on matrix B. And when you're adding matrices, you add the corresponding elements in each matrix. So for example, the first thing we do would be add the 2 to the minus 4. Minus 3 add 5. 4 add minus 1. And 1 add 2. So that is the result for A plus B. If we're doing B plus A, we've got to get the matrices in an appropriate order. So this would be matrix B first. And we're going to add on matrix A. And again, you add the elements in the corresponding position. So minus 4 plus 2, 5 add minus 3, minus 1 add 4, and 2 add 1. So we can see here that A plus B gives us the same answer as B plus A. In fact, matrix addition is commutative, and A plus B will always be the same as B plus A for conformable matrices. If we consider subtracting matrices, again they need to be conformable. So here we are doing A take away B, and if we're subtracting, we would subtract corresponding elements, but being very careful for negatives and double negatives. So we've got 2 minus minus 4 is 6, minus 3 minus 5 is minus 8, 4 minus minus 1 is 5, and 1 minus 2 is minus 1. We're allowed to multiply matrices by a scalar value, so 3 times A is 3 lots of 2 minus 3, 4, 1. And you just need to remember to multiply every element by the scalar value 3. So 2 times 3 is 6, 3 times minus 3 is minus 9, 3 times 4 is 12, and 3 times 1 is 3. And likewise multiplying by minus 2. So we've got minus 2 times C. And we've just got to make sure we multiply both elements by minus 2. So that's minus 2 times 3 is minus 6. Minus 2 times nothing is nothing. In this example, the first matrix shows the results of the league after the last 3 games have been played and before the last 3 games have been played, and what we need to work out is the results of the last 3 fixtures, which were City v United, Rangers v Town and Rangers v United. We can do that by subtracting the matrix after the last 3 games and taking away the matrix before the last 3 games, and again just taking care with the corresponding elements. So we have 4 take away 3 is 1, 1 take away 1, 1 take away 1, 12 take away 10, 8 take away 7, 1 take away nothing, 1 take away nothing, 4 take away 4, 5 subtract 2, 12 subtract 10, 3 subtract 3, 1 subtract 1, 2 subtract 1, 12 subtract 11, 10 subtract 8, 1 subtract 1, 3 subtract 2, 2 subtract the 1, 10 subtract the 8, and 9 subtract the 6. So these are the results of the last 3 games for City, Rangers, Town and United. So if you look at the top row, we know that City only played 1 game, so this is their 1 game which they won, and they scored 2 goals for and only 1 goal against, so they must have been City 2, United 1. Likewise, if you look at Town, they played 1 game which they lost, they scored 1 goal and conceded 2 goals. So Town scored 1 goal and conceded 2 goals. And similarly, you can work out the result of the last game, which was Rangers 1, United 1. In the next session, we're going to be looking at 1.2 multiplying matrices.